Hey everyone, I'm Dawson Moros, and welcome to my presentation about my Sisyphus table. The Sisyphus table is a kinetic art piece that draws in a bed of sand like a Zen or rock iron. The table gets its name from the Greek myth of Sisyphus, who was punished by Hades for cheating death. Sisyphus was forced to roll a rock uphill only to have it roll back downhill before reaching the top for all eternity. Likewise, the table creates pieces of art in the sand only to erase it to make its next piece of art. The table works by using a selective compliance articulated robot arm, or SCARA. My SCARA has 2 degrees of freedom, like the one pictured here. The arms are driven independently from each other using 2 stepper motors. Both arms can spin freely indefinitely, allowing for the robot to complete many rotations needed to draw its art. Here's the robot itself. Each arm has an indicator that is used in conjunction with the beam brake sensors to home the machine. Turning the robot over, I can demonstrate how each arm moves independently. The red arm is controlled by a motor connected to the brown pulley in the center of the robot. This pulley spins freely on the shaft of the black arm. Then the long belt loop transfers the movement to the elbow joint, moving the red arm. The black arm is driven from the bottom of the robot, shown earlier. You can see that if the red arm is held at a constant angle, I can move the black arm without spinning this brown pulley. Here's the controller for the robot, which uses the ESP32 and its dynamic stepper drivers to drive the stepper motors. Opening the robot, you can see the shaft of the black arm as well as the 2 stepper motors that drive each arm. Let's move on to the demo of the web interface of the robot. I've just sent the homing command to the robot. The robot homes both arms at the same time thanks to the position of the sensors. I can then send the command G28 to return to a preset position, in this case, the 0 position. Refreshing the SD card box gives me access to all the files preloaded on the SD card in the robot. I can upload files directly from the computer to the robot without running the SD card, and also run any of the files on the SD card. Here I am running the program from the beginning of the video. I can also cancel the current program from this interface. Let's take a moment to review the pre-processing code of the robot. In the main section of the program, it asks the input and output file name as well as a couple optional settings. Moving along, we have the parse G-code function. This takes the input file line by line and reads each parameter, passing the parameters to the write G-code function, whose job it is to write a new line of code to the output file. This function handles the scaling of the speed of the machine based on the current radius, as well as breaking large lines into smaller lines to increase the resolution of the robot. Lastly, write G-code calls inverse kinematics. Inverse kinematics converts Cartesian or XY coordinates to our SCARA movement. It is the core of this program. It also keeps track of the looping of the robot to ensure that the robot always takes the shortest path to its destination. With that, this is the end of the presentation. Please enjoy this time-lapse footage of the robot and the pattern it's drawing. Thank you for watching.